Hello, this lecture is about the topic of joint cognitive systems and situated cognition. So this is the first in 3 presentations that relate to this topic, and what I'm going to be talking about is introducing some of the theories that really articulate this notion of joint cognitive systems, talk through some case studies, and then specifically focus on a notion that's known as sense making. So in this lecture, I'm going to be explaining the importance of considering all aspects of the work system when we're designing new technologies or systems. I'm going to particularly focus on an approach called the Joint Cognitive Systems approach and talk through some of the elements of this approach. Now, this particular approach is quite interesting as well because its own authors have more recently almost reconsidered its value. I'm still quite a supporter of this particular approach. I think it sends a really helpful message, but it's useful for you to just think about whether this is something that's useful in the context of thinking about how we implement cognitive ergonomics in the workplace. So when we consider the human-machine system, we, in general, and if you think right back to the sort of notions I presented at the beginning of the lecture series, we talked about the specific aspects of human cognition. Well, when we're talking about what potentially is known as the human-machine system, we often distinguish between 3 distinct elements: the human, the machine, and then the interface, which is the bit that connects the two. And this implies a sort of an input-output type scenario that we then end up thinking about. But it's worth thinking about what this actually means in terms of the interaction. So if we separate very clearly the person and the machine, we're sort of implying a quite separate relationship. It doesn't really speak to the notions of collaboration and cooperation that we know are so important for an effective workplace. So a joint cognitive systems approach argues that it's more appropriate to think of the functions of the joint system as a whole rather than necessarily separating that system into its individual components. This potentially thinks about, if we think back to some of those biases we talked about in decision making and that isolated decision making. Well, one example of poor isolated decision making is designing a single component of the system rather than thinking about how all of the different elements of a system work together towards a common goal. So Eric Hollnagel talks about this traditional view of human-machine interaction or the human-machine interface. So it's very much what we call an input-output model. We've got the person on one side, the machine on the other side, and there is an assumption that the way in which they communicate with each other is this sort of a giving of information, a processing of information by the other part, and a response back. So it's a very transactional type of model. Now, this may technically be what happens, but if we're thinking about how we're designing a cognitive system, it's much more effective to think about the incorporation of the system as a whole. So Hollnagel argues that the information processing approach to human-machine interaction focuses on the inner process of the mind, and it does. That's what I've taught you in this module to a certain extent. And the criticism that Hollnagel brings is that this implies very much this input-output approach. And if we think back to what Norman and Draper talk about in terms of the gulf of evaluation and the gulf of execution, we can see how that plays out. So we've got this notion of a gulf that we've talked about before. The execution is where we sort of struggle in terms of that interface, in terms of not necessarily being clear on what our allowable actions are. And then the gulf of evaluation is the amount of effort that needs to be exerted to determine whether the expectations and intentions have been met within the system. So Hollnagel argues that this disintegrated view of the human-machine interface means that actions are treated as a discrete series of events rather than a continued flow of actions and events. And that means that therefore we don't necessarily see that complete picture of the way in which a system works. It also notes that users are represented as single individuals and disregards that fact that humans always depend on others, even though they may be removed in time and space. Remember that onion model right at the very beginning, and in the middle we've got people, technologies and artifacts. The reason that there's those intersecting Venn circles at the middle of that box, and that it says people, not person, which you'll notice is a change in the onion model from previous versions, is that that joint cognitive system really talks about this interaction between people, technologies and artifacts. And if we think back to situation awareness, that the focus is on anticipation rather than a combination of simple or complex responses. So the influence of a situation or a context, therefore, is indirect in this disintegrated view, and there's only so much we can fit into the input categories. So it fails to take account of those bits around the outside of the onion model that were so important. And that because the models are quite structural, the emphasis ends up being on the structure of the inner processing mechanisms rather than their functions. So I'd really encourage you to take a look at this video that's called My Colleague the Robot. It's a really short video. It's a great video actually, and it talks about the introduction of technologies into the workplace and actually starts to argue that we should really be thinking of technologies as actors in the workplace in the same way as we think about people as being actors in the workplace. Now I want to move on now to another specific theory. It's a very, very old theory. I think it's, I should have put the date on, I think it's 1908 that the Yerkes-Dodson law was first proposed. Yerkes-Dodson really is a great articulation of the relationship between what we talk about as arousal, alertness, engagement in a process and the resultant performance. And you'll see a lot of similarities to this to some of the models we talked about in workload, particularly explaining that notion of underload that we identified as well. So in the Yerkes-Dodson model, we have, so I'll just squidge forward a little bit here, on the y-axis, we've got the notion of performance, and at the bottom, we've got poor performance, and at the top, we've got good performance. Oopsie, hold on. There we go. Then on the x-axis, we've got arousal, moving from low to high. And what Yerkes-Dodson argues is that in this particular scenario, as arousal increases, so as the demand, the engagement of the task increases, performance tends to decrease, but there's an optimal, performance tends to increase, but there's an optimal level of arousal that we reach that's associated with the best possible performance. Now we can see instantly this is an oversimplification. If we remember the workload model, there was a much wider period in which optimal performance was feasible, but the notion is really interesting. So the point that Yerkes-Dodson law makes is that we don't necessarily have to continually decrease arousal, but that there is an optimal level of arousal that leads to the most effective extent of performance. And that, of course, the difference between the complexity of a task will also affect the optimal level of arousal. So for a more simple task, it might need to be more sort of demanding or engaging than a complex task, because the complexity itself brings a level of arousal that is helpful. The point of introducing this here is that this is thinking about the performance of people within these complex systems. So building on from the consideration of the Yerkes-Dodson law that really just, I suppose, highlighted the importance of consideration of arousal in design of a workplace. This particular model that was put together by Karasek in 1979 talks about the notion of stress. And the reason that stress is relevant to the topic of today's lecture is that it's one of the psychological components that people bring to the joint cognitive system. So the psychological approach to stress accounts for the influence of perceptual, cognitive and organisational factors. And it focuses on the areas where there might be a challenge in terms of workplace design, as being where there is something called unresolved strain, so a mismatch potentially between the demands placed upon the individual and the decision latitude. So decision latitude that you see on the left-hand side of the diagram refers to the amount of control or influence that an individual has over the way in which they do their job. Now, this isn't a new concept to us. When we looked at workload, for example, we looked at the differences in different types of pacing types of task, and we also looked at something called temporal demand. Well, temporal demand is a good example of where there is low decision latitude because the time that is placed upon you is really limited. But decision latitude is more broad than that because it focuses on the choice around the strategies that you might use, or the methods that you might use, or the order in which you complete your tasks. So on the left-hand side, there's a distinction between low and high decision latitude. And then at the top of the diagram is the distinction between the overall demands placed upon the individual by the job and whether they are low or high. And there are 4 segments within the diagram. The first is when there's low decision latitude, so there isn't much choice over the way in which you complete a task, but the demands on that task are also low. So an example of this might be working in a shop where you sort of have to do the tasks and there's sort of no choice about how or when you do the task, but the actual level of demand, if the shop is quite quiet, is quite low. If we also think about another situation, though, where that decision latitude is low, but the demands are high, such as a really, really busy shop where there's no choice about the way in which you complete a task, but for example, the number of customers is very, very high, then that can potentially end up being a high strain job. If we go to the bottom left of the diagram, that's the situation where the job decision latitude is high. It's almost the ideal situation if you think about it, where you've got lots and lots of control over how you do the work, but the job demands are low. An example might be a self-employed writer, where you've got a lot of control over the amount and the nature of the way in which you work, and the demands are low, assuming, of course, that your financial reward is sufficient, that you don't have those worries. And then probably many sort of managerial jobs fall into the bottom right-hand corner, where job demands are high, but job decision latitude is high. My job definitely falls into this category. I have lots of control over the sort of order in which I do tasks, but and the nature and the strategy that I use to do tasks, but the demands are very, very high. And that's quite common of professional types of environments. And the point that's highlighted by the job strain model is that psychological strain results from the joint effects of the work situation and the control available, and that job strain occurs when job demands are high and decision latitude is low, and that incremental additions to competency occur when the challenges of a situation are matched by the individual's skills or control in dealing with the challenge. So an active job will lead to new behaviour patterns both on and off the job. So there's a transfer potentially between the workplace situation and the out of workplace situation. But a passive job induces a decline in overall activity and a reduction in general problem solving activity, potentially feelings of learned helplessness. Another model of stress, and this has got an element that I'm really very keen on, was put together by Cox in 1987, and it relates to the sources of the demand relating to the person and the external environment. And the particular message that this model talks about is that stress arises when there's an imbalance between the perceived demand and the person's perception of their own capability to meet the demand. So it's not necessarily their actual capability of meeting the demand, it's their perception, their confidence. And so this notion is called cognitive appraisal, which takes account of the perceptions of the demands on them matched against their own coping resources and personal characteristics. So we can see a couple of challenges here. We can see, first of all, that you may misunderstand the demands placed upon you. You may overestimate them and feel that you haven't got the confidence to be able to meet them. You may underestimate them and be overconfident about your ability to meet the demands placed upon you. It also highlights the constraints under which an individual has to cope and the support from others, so starts to bring in that notion of people working collectively in a workplace. And the key contribution that this model makes is it identifies that stressful situations are those in which a person's resources are not well matched to the level of demand placed upon them, and where there are constraints on how well they can cope. So the opportunity to actually get additional support in how you can cope is not necessarily there. So this diagram here shows the transactional model of stress from Cox. We can see at the top that there's this notion of cognitive appraisal, where the imbalance between the perceived capability and the perceived demand can lead to stress. You can see that just at this point in the diagram here. It also highlights this difference between the actual capability and the perceived capability, so there can be a mismatch there, and the mismatch between the actual and the perceived demand. It also notes the emotional experience that results from experiencing stress and a physiological stress response as well as a psychological stress response that leads to a cognitive defence and a behavioural response. Now, the nice thing about this model is it explains both positive, almost motivational features of a situation that's quite demanding, as well as when this can be a negative experience. So a negative experience might be that you're feeling really overwhelmed by a task, and so your behavioural response is to do nothing, to procrastinate quite a lot, and therefore actually, of course, you're not doing anything to minimise the demand, and you're potentially even reducing your confidence in your ability to meet that task. Alternatively, I'm someone who gets quite motivated by a deadline and works quite well to external pressures. So for me, having that sort of motivational stress response means that I work really hard, and therefore the actual demand is reduced, the perceived demand is reduced, and therefore I feel more confident about my ability to actually achieve the task that's been placed upon me. So the really, really great thing about this model is that it highlights both the balance between capability and demand, so takes into account individual and group capability, but really focuses on this notion of perceived versus actual. And as cognitive ergonomics designers, that's something we can influence. So we can help people more accurately judge the demand that's placed upon them. We can also potentially help people more accurately judge their capability to meet them. For example, by we see this done really nicely actually in newspaper articles that you read online now that say things like, this is a 6-minute read. And so that's a good design intervention that helps us to both judge the demand placed upon us by reading that article, but also we think, well, have I got time to read a 6-minute article? Am I a fast reader? Is it really only going to take me 4 minutes? And that can be incredibly helpful in terms of judging whether this is something we can cope with or not. So we've talked about 2 topics so far. We've talked about some of the challenges around the disintegrated view of the human-machine interface, and then we've talked about one of the things that people almost bring to the party in terms of their psychological and physiological response to demanding and stressful situations. And these are both relevant when it comes to considering the joint cognitive system. So the joint cognitive system was proposed to really take away the emphasis from interaction between human and machines to have this harmony and cooperation approach, and it allows for expansion with respect to multiple people or machines, and takes away that need for representation of detailed processes. Now, it's worth saying there's a negative to this, and the Eric Hollnagel article that I've popped on the Moodle is really interesting from this perspective, because he, I think personally slightly wrongly, sort of gives up on the idea and says, oh, it's not worked as a notion. I still stand by it, but it's not worked. I think it has worked as a notion, but the challenge with joint cognitive systems is it didn't deliver sufficient usable methods to help engineers and designers understand how to take this notion forwards into their everyday work. And so thinking about that is something we need to really focus on. So the cyclical cognitive systems engineering that Hollnagel and David Woods put together is something that builds on another notion that we'll talk about in a couple of sort of presentations time, Neisser's perceptual cycle. And you can see that it basically describes a continuous loop. So we haven't got a stimulus response model here. There isn't an input-output approach. It's a continuous loop of receiving information, informing a current understanding, and deciding on and determining your next action. And that action then updates the information feedback, modifies current understanding, which then directs the next action. We can see real similarities here with Donald Norman's 7 stages of action that I talked about in the Mental Models and Design lecture as well. So the notion of the joint cognitive system is that we think about people, technologies and artifacts all working together, and that the system is able to modify its behaviour on the basis of past experience so as to achieve specific ends. It's really important that we consider this as being the system. Obviously, we've talked about, for example, the transactional model of stress and the ability of people to continually get that feedback. But of course, we're increasingly seeing technologies also learn from their environments and continually get that feedback as well. So the cognitive systems are able to control what they do. So the characteristics of the joint cognitive system are that we describe human behaviour as a coherent series of actions rather than a collection of single separate responses in some way. With analogies to situation awareness, there's a really strong focus on anticipation and response. And that in a cyclical model, performance can start anywhere. So an action's not necessarily a response, but could be in anticipation of something, an anticipatory action to preempt or prevent something from occurring. And when we talk about system resilience, often a really great resilient system is anticipating a future event. Users are seen as part of the whole, and the user and the environment are dynamically coupled, and there's a lot of mutual dependency between actors and events. And there's an influence of the situation or the context which is direct and affects the user's way of working. So no longer are we looking at these systems in a vacuum. We're actively recognising the social and the organisational setting of the collaborative work. So specifically, we're thinking about how events are evaluated and how actions are selected, as well as the user's way of working. Now, there's a really interesting challenge presented here, because if we're looking at attribution of responsibility or regulation, suddenly we're in a bit of trouble, actually, because there was actually something quite helpful about distinguishing between individual contributions and technical contributions, because you could really clearly say, well, I hold this part of the system responsible for this part of the system responsible for this. So in things like regulation, this becomes very challenging. I'm doing quite a lot of work with organisations like British Standards, looking at regulation as we move towards a more collaborative robotic type situation, because there are some real challenges presented here. So this diagram represents what we call joint system boundaries. So just highlights what in practice a joint cognitive system might look like. We might have the driver and the car working together. They're embedded in a setting that comprises of roads and traffic infrastructure, and then that's influenced by the weather and the environment around. And then this example looks at the air traffic control system. So we've got flight tech technology, pilots, controllers and air traffic control technology, and they're all working in partnership together. In a way, I probably shouldn't have these arrows there. We used this analysis when we were looking at a particular technology called data link. We were looking at how data link technology might change the way in which communication or interaction took place. And this was almost sort of text messaging between different parts of the aircraft infrastructure that happens in transatlantic flights already. And what we highlighted was that it wasn't just that data link was going to be affecting the interaction between the pilot and the controller, but that it interacts with all elements of the system. Similarly, another method that we were looking at, which was free flight, so pilot mediated air traffic control. There isn't an air traffic controller, but there is a pilot who is working directly with other pilots in order to negotiate different patterns of travel. This happens in private jet environments, for example, where there's very low density. So in New Zealand, private jet owners, particularly in the agricultural setting, may well use a method of free flight communication, for example. And what this really highlights is the removal of the focus on the pilot to the controller, in this case, but a much more joint cognitive systems approach. So this short presentation has really tried to highlight how we can think about new technologies and systems affecting the joint cognitive system as a whole. We're moving away from this input-output type approach and thinking, right, what does holistic thinking help us to understand in this particular context?